see my presentation file, yes?
Yes.
Okay, let's start lecture 4, which is about the sources and availability of water in both global scale and country scale. Last session, we talked about first part of water supply. As you know, we said that water supply includes 4 components, including demand, source and availability, treatment, and water distribution. About water demand, we talked about demand of different cities in Turkey and how we should calculate water demand in order to move forward to design water supply systems. Now, in this lecture, I will talk about sources and availability of the water. So, as we know, water distribution in space and time, you know that the amount of water on the Earth is constant, actually, because of the conservation of mass, but its distribution varies at time and space. I mean that it is possible that in somewhere we have, for example, drought effects sometimes, but in the same way, same location, and in another time we can see excess water or flood events. It means that water distribution varies temporally, or it is possible to see in some countries that the country is rich, for example, in terms of water resources, but after several years, the country's situation can vary and can be poor in terms of water resources and water availability. Therefore, we should consider the variation of water availability in time and space. This is why we should manage water resources in a way that in the future we should save or store some water for potential reduction in the water availabilities in the future. More details will be talked in this lecture, but let's continue with the global availability of water on the Earth. As you know, more than 70% of the area of the Earth is covered by water, yes? Or we say oceans, or water bodies cover more than 70% of the Earth. But this not means that we, in terms of, human or living things, such as animals or plants, are enough water to be alive. Because this water or water that we have in oceans are salty and not useful for drinking. So in this table, we see how different water bodies have how much water at different locations. For example, in this table, we see that oceans have about I'm talking about this line. Anyway, I said that oceans cover approximately 95% of total water of the Earth, yes. And its volumetric amount is like this value, 1.3 thousand cubic kilometer. After that, let's see. Yeah, this graph shows better, and we can easily discuss the amount of water on the globe more easily. As you see here, about 97% of the water is in oceans. Therefore, they are saline, and out of the access to use as a common water sources or common available water sources. And the freshwater amount is approximately 2.5%. About these 2.5 or 3% of fresh water, as you see, again, approximately 69% is in the glaciers. Okay, and again, this water is out of access. And if we see this part, it means that approximately only 30% of the available water or available fresh water, which is not saline, is underground water and surface water. So in total, this value is the main source of current use of water in both industry and agriculture, and also in domestic water uses. Among this water, 30% is groundwater and 1.2% is, as I told, is fresh water. That is a kind of water which is on the surface. However, most of again, about 70% of I talked about ice, and 70% of the fresh water is underground, like ice or permafrost. I will talk more about it in the next slide. And lakes and streams, rivers, wetlands or swamps cover really on neglectable amount of water. However, this is what we use commonly in Turkey. Actually, the main water resources in Turkey is surface water, I mean this part. But in some arid countries like in Iran or Saudi Arabia, this part, groundwater, is the main water resources. However, recently, ocean also, seawater or water from oceans included in the water use cycle for human and other applications. Okay. As we told, surface water includes those part of water that can be seen in swamp, wetlands, marshes, and also we can see some surface water in forms of snow, like snow patch. And as I told, some ices are underground that we say permafrost. This permafrost, this figure shows a permafrost, and as we saw in the previous slide, permafrost and underground ices covers about 70% of surface water, surface fresh water. Let's come to here and talk about the differences between swamp and marshes. And sometimes interchangeably students use these terms, but there are distinct differences between swamp and marsh. A swamp is a wetland. Both are all wetland, okay? But a swamp is a wetland, as you see in the figure, that is forested. It means that you can see trees in swamp. And many swamps occur along large rivers, where they are critically dependent upon natural water level fluctuation. However, a marsh is a wetland, this figure, that is dominated by herbaceous rather than woody plant. You see, there is just herbaceous without tree, without seeing trunk of such trees. Marshes can often be found at the edge of lakes and streams, where they form a transition between aquatic and terrestrial ecosystem. So many wetlands that you saw in Turkey are marshes, not swamp. For example, if you move close, if you visit the border wetland, you will see such a marshes close to the Antalya. Okay, let's talk about the common water sources more in detail. As we said, water on the Earth was stored as groundwater or seawater or surface water, and we have also another kind of common water sources, which is called reclaimed or recycled water. In today's lecture, I will talk about these items individually. Okay, let's start with surface water situation in Turkey. As I told, main sources for surface water are rivers and lakes. Yes, rivers and lakes or swamps are main water sources. Regarding surface water in Turkey, we know that average precipitation, it means long-term average precipitation, in Turkey is about 574 millimeters, which equates to about 450 billion cubic meter of water. What does it mean? It means that each year, entire Turkey receives approximately 574 millimeter of rainfall. If we multiply this amount at Turkey area, at the area of the Turkey, it gives us total amount of water that annually we receive from the sky in entire Turkey. It's equal to 450 billion cubic meters, BCM. Surface water potential that can be used for various purposes average 94 BCM per year under today's technical and economic conditions. It says that also the country receive 450 BCM water, surface water. Among these water partly moves down as to join to groundwater, but partly are stored at reservoirs behind the dams, and some part moves to the sea, yes, or to the lake. Among those that moves to lakes or to the sea, which is called surface water, 94 billion cubic meter is the what we use. Turkey consumable surface and groundwater, if we consider groundwater also among this value, the total consumption of Turkey's consumer surface and the total consumption of Turkey is 112 BCM per year, of which 57 is utilized. It means that in general, let me summarize in that way. Each year, the country receives 450 billion cubic water, okay? Among this water, we can store 112 BCM in our lakes, our dams, reservoirs, and also at groundwater. And the other part, I mean that the difference between this value and this value moves to the sea, and the 57 BCM is utilized at entire country. Can you guess in which area we use most of the water? As I told, we have three sectors: industrial, Domestic use, industrial use, and agricultural use. Which one takes more water in your opinion? In Turkey?
Agriculture.
Yes, you are right. Agricultural water use is the sector that use most of the water that we receive. Okay, this map shows hydrological basins of rivers or the main hydrological catchments of entire Turkey. I mean that what comes as a rainfall across the country finally moves as a runoff to join to these rivers. The map shows that we have 25 hydrological basins or river catchments in the country, and also some lakes like Van Lake at eastern Turkey, Burdur Lake, Konya Lake, Loz Lake, and some other at western Turkey. More detail about this surface water network. It is called surface water network of the country. Turkey is divided into 25 hydrological basins. These river basins each have a different catchment size and a wide range of annual precipitation. I mean, it means that we receive about 574 millimeters of rainfall per year. It does not mean that this rainfall uniformly rains on the country. Maybe some part receive less, some other part receive high, but the average of the country is about 570, and in some texts you might see 600. The average rainfall of the country, 600 millimeters. This, okay. Evaporation and surface runoff variables. Yeah, evaporation also is different at different location. Definitely at southern part of the Turkey, where the average temperature is higher, the amount of evaporation is high. As a result, river discharges are unpredictable. Yes. Within Turkey's borders, 16 rivers rise in the mountains and flow into the Marmara Sea, Mediterranean Sea, Black Sea, and Aegean Sea. Out of these 25 hydrological basins, 16 are those rivers that finally end to Black Sea, Mediterranean Sea, Aegean Sea, and Marmara Sea. However, we have also some closed basins like Konya Basin, Akarçay Basin, Burdur Lake, and Lake Van are those of closed basins, which means they have no outflow to the sea. What comes to the basin moves finally into the lake that exists in the basin. And we also have transboundary basins or transboundary rivers, including Martiza, Asi River, Aras, and Euphrates and Tigris, and Choro Basin. The rivers that cuts the boundaries are called transboundary rivers, like Euphrates and Tigris, that you see originates from Turkey but continues in Syria and then Iraq and finally releases to Persian Gulf. So the other transboundary river is Choro River. You see that Georgia and and Turkey share some waters of Choro River. And Aras we have here, Aras River. Yeah, this is Aras that again originates from Turkey but moves through the Armenia, Azerbaijan, and even Iran. Then finally releases to Caspian Sea. And in Western Turkey, we have Martiza. The Turkish name should be Meriç River, which The river is shared between Bulgaria and Turkey and also Greece. And yeah, we talked about all these transboundary rivers. Any questions so far? No.
No, sir.
Okay, now about surface water, we talked that they're commonly stored at rivers and streams and lakes. And we saw that the river networks of the country, all the surface water have some common features. Do you guess what are the same feature environmentally? We are talking about environmental features of water in the rivers. Here I listed 3 common features of surface water. First of all, easy to abstract. What does it mean? It means that for domestic, industrial, or agricultural use, we can easily take water from surface water. Just the one pump like you see here is enough. Yeah. So abstraction of water is easy from the surface water. The second common feature at surface waters are they are easy to be contaminated. Yes. Another figure. As we talked, it is possible due to the point pollution or non-point source of pollutions, like you see here, point source, non-point source. You see, surface water can get easily polluted. And the third common feature is high in TSS and pathogens. TSS should be defined or described more in this slide and the next slide. TSS is the abbreviation for total suspended solid. You know, some solid materials always available in surface waters. Generally, I mean about solid material, we are talking about natural material, which can be sand, soil, or gravel. These materials or sand moves along the river either in suspended form or on the bed, and also we have some dissolved material. Dissolved, that means very, very small size of soil can be dissolved in the soil, in the water. Therefore, in rivers, total TSS, which is total suspended solid, is commonly high. And also pathogens. Pathogens, those microbes and bacteria that make or viruses that make some diseases, always available on surface waters. Here, some extra information is given about the TSS. As I told, total suspended solid are particles that are larger than 2 microns in diameter and are suspended in water. Okay, this is why we say TSS. They can come from a variety of sources, including soil erosion, as you see here. Due to soil erosion, the soil moves into the water and moves by water down to downstream and creates turbidity. It means that water color moves dark, goes to be darker and close to be, for example, brown. It is therefore, if we see some rivers with brown color of water, it means that TSS amount is too high in that river. And also TSS can be originated from sewage discharge and industrial wastewater. TSS can cause turbidity in water, which can make it difficult for aquatic plants. For turbidity, we say bulanıklık in Turkey. Okay, so high TSS means higher turbidity. And if the water has higher turbidity, it is not suitable for irrigation, and it is not suitable for plant growth. Also, it makes difficulties for photosynthesis, and also can clog fish gills, which might be result in the death of fish. High levels of TSS can also indicate the presence of harmful bacteria and other microorganisms. So from environmental perspective, TSS of the rivers are high, and in order to understand if any river has high TSS or low TSS, we check its turbidity first by eye. We can distinguish if the amount of turbidity is high or low, and then for detailed analysis, turbidity meters and some other instruments can be used. Okay, the second common water resources are groundwater. If you pass hydrology already, we had some sessions about groundwater, but if I want to summarize it in 2 or 3 minutes, we can say that depend on the soil infiltration rate or soil porosity. When we have rainfall, some moves moves downward, and we say it is infiltrated to the soil. And by the time this infiltrated water moves downward again to join to the aquifers or groundwater resources, the process is called percolation. And we have two kind of groundwater. Either in general we say aquifers or groundwater bodies or aquifers. Two kind of aquifers we have. One is called confined, the other is unconfined. Unconfined aquifer is this one, which is a kind of aquifer or water body which has only one boundary with impermeable layer. It means that from one direction, here from up to down, groundwater can move to join to aquifer. But if two sides of an aquifer is impermeable layer, like here we have a silty layer. Silty layer is famous to be an impermeable layer, and the other part is bedrock. Okay, it means that there is no penetration or sewage from up to or down into the groundwater. It is, in that case, the aquifer is called confined aquifer. The main difference between confined and unconfined aquifer is the pressure. Actually, confined aquifer has very high pressure, and unconfined has actually no pressure. And here in unsaturated zone, in terms of pressure, we have negative pressure here. The pressure at aquifer is actually just dose of pressure that we have learned in fluid mechanics, equivalent to the depths of the water, gamma h. But extra high pressure we have here. If we drill a well like this, in aquifer or unconfined aquifer, this well water surface will be exactly at the location of water table, which is also upper freeze or upper surface of aquifer. But if we drill a well like this here in confined aquifer, due to high pressure exists in the aquifer, water moves up from the well and releases out, which is called what? Artesian wells. Now with this introduction about the groundwater, let's see groundwater availability in Turkey. As you see, the information is from since 1950. Main groundwater of Turkey are aquifers and springs. As mentioned earlier, Turkey's total usable water potential, total usable, is groundwater plus surface water, is 120 BCM, of which 94 was surface and 80 is groundwater. Therefore, in total, 18 billion cubic meter of groundwater can be used in the country per year. Turkey groundwater operating reserves, operating reserves total, as I told, 18. Also, only 16.60 BCM have been allocated as follows. Therefore, annually, the government allows the users to dig some wells and use groundwater for different aims. How much? 16.62 BCM. About 2 BCM is stored underground from our annual groundwater receives. Out of these 16, 11.21 BCM is used for agricultural irrigation by individual irrigations, public and cooperatives. 1.5 BCM is used for water, industrial water, and 3.9 BCM is used for drinking. Okay, so as you see here, most of the groundwater usage in the country is for agriculture. And also we know that, as one of your friends told, more than 70% of water usage in the country belongs to agricultural, irrigation, and agricultural sector. Okay, there were 370,000 certified wells as of the end of 2019, with 38,000 for drinking, 17,000 for industrial, and 300,000 for irrigation. Let me see if I have no. You know, when we talk about groundwater, we should talk about wells, and when we are talking about the wells, certified wells and or uncertified wells are also available. The information shown here belongs to certified, the wells that registered in water authorities. But there are definitely thousands of unregistered wells. Just a minute. You see here, by the information given in 2019, they said that we have 369 registered wells. And I assume that at least 10,000 unregistered wells also available. So some part of the groundwater is used without being recorded. Okay, this slide shows us the common features of groundwater. As you see in the figure, by contrast to surface water, groundwater abstraction is difficult. Yes, as I told, we need wells or we should construct canals to abstract water. And in some cases where the groundwater level is too deep, high technology is needed to construct these wells. The second common water feature is about the contamination, and as the water stored underground, several meters underground, its contamination is difficult because the polluted materials or polluted water should move through the soil layers to reach groundwater. Yes, but soil acts like a filter that keeps the pollutant and just allow to pure water moves downward to groundwater. However, if the groundwater gets polluted, it is really difficult to clean up the polluted groundwater. The other common feature is unlicensed, as I told. Yes, unlicensed well digging is hard to control. Unlicensed or unregistered wells cannot be easily detected and controlled. The last common feature, by the way, this title is not surface, it should be ground. Okay, let me correct exactly just one. Let's common ground. Ground, yes, that's true now. Yeah, the last common feature of groundwater is low in TSS but high in TDS. Can you guess why TSS is low in groundwater? Written there. Due to soil filter, yes. Because soil cannot move down. Only water moves down to the groundwater. Therefore, suspended solids are not are very, their amount is too low in groundwater. But it is possible to have high TDS, which is called total dissolved solid. Yeah, very small particles can dissolve in water. Therefore, TDS amount at groundwater can be high. So can you guess what is the difference between TDS and TSS? As I told, TSS is the particle with higher than 2 microns diameter. If the average diameter is less than 2 microns, it is called TDS. Definitely, sometimes I ask this, what is difference TDS and TSS as a question in exam. So we talked about groundwater and surface water. These are two main water source of the country. So we can summarize these two parts in this figure. Turkey's water budget and components. As we told, annually the country receives 450 billion cubic meter of water. And we have also 220 BCM evaporation, okay? Out of these value surface, we also receive some runoff from neighbor countries, especially from Bulgaria, yes, and some other neighbor countries. The total water income is 6 BCM. Out of this water, 181 BCM is surface runoff. And out of that value, 45 BCM moves to aquifers or leakages to aquifers. Potential of the country to use surface water is 94 BCM, and our potential to use of groundwater is 18. And in total, it is 112. And actual consumption of the country is about 50 BCM. Maybe some values, 1, 2, or 3 BCM can be changed based on different slides and different sources that I have used. Sorry. This graph also shows that in 2016, 74% of total water of the annual water of the country was used for irrigation, 13% for domestic, and 13% for industrial uses. So the main and significant part of water that we receive is used for irrigation and food production in the country. Any question? Okay, the third common water sources in general is seawater. And as you know, seawater is the water that obtained through desalination process, because seawater or oceans are saline, and we need desalination to change seawater to fresh water. There are many ways for desalination, and the 4 common or popular ways include desalination, distillation, reverse osmosis, electrodialysis, and ion exchange. Desalination in general means you see that the salt water and the salt is taken from the water through the heat, for example. The process is called desalination. Water vapor moves up, then through the cooling, this water vapor can be condensed and clear and create fresh water. These different methods of desalination might be discussed separately in another lecture in this course. Any question? Okay, the common features for seawater are listed here. High in cost. Desalination is because desalination is needed, and it means that we need high energy to remove the salt from seawater. And because of high price to create energy, the entire desalination or use of seawater process is difficult. In this figure, you see Al Jubail water desalination plant in the Saudi Arabia. The other feature of desalination of seawater, common feature, is being problematic in disposing brine wastewater. Yes, this part. Brine wastewater means salty wastewater or salty waste. When we desalinate, okay, fresh water is taken, and still we have some salty water, yes, which is called brine. Where we should deposit this salty water? If we replace it again to the sea, we have very problematic situation in the sea. And one of the main problems in in the use of desalination plants like this is the disposing the brine wastewater. And the last common feature is that this method is suitable for coastal cities, yes. And if there is no coastal city, access to sea or seawater does not make enough sense to first desalinate with huge amount of cost, then transfer, for example, hundreds of kilometers to the end user. Okay, this is the third water resources. How about your opinion in country, in Turkey? Do we have such a desalination plant in Turkey? Have you heard about it? So this is topic for your research. Search about seawater use in Turkey. It could be a topic for one student. If there is some paper, you can find it. But in general, as I told, Turkey's main water resources are groundwater and surface water, and especially surface water, then groundwater. And the last common water resources that is used in several countries is called reclaimed or recycled water. The process is shown here. For example, water reclamation is the process of converting municipal wastewater or industrial wastewater into water that can be reused for a variety of purposes. Types of reuse include urban reuse, agricultural reuse, environmental reuse, industrial reuse, plant potable reuse, blah, blah. In detail, we have, for example, some wastewater at home, okay? For example, we take a shower or hand washes, dishwashers, or a washing machine. We use these clean water or fresh water, but these after that step we have wastewater, yes. With a system of recycling, it means initial treatment. The recycled water can be used for some purposes. For example, in a domestic home, we can use this recycled water as the water in toilets, in the toilets, or to irrigate our garden. Instead of using tap water, reclaimed water or recycled water can be used for watering the garden. It is also called grey water. And this kind of water that is used after initial treatment at domestic treatment plants, very small. For example, think about small instruments that we install them at home, then the wastewater from, for example, washing machine is treated, then it can be used in to flush the toilets. Here I saw a paper that the topic was actually for previous year students, was suitable to study this paper and provide some information. Water reuse in Iran with an emphasis on potable reuse. You see, maybe such a topic can be searched for Turkey, water reuse in Turkey with an emphasis on potable reuse. Is there any reuse in order to create water for domestic use? Actually, in the US, we have some treatment plants that they treat water 100% and then supplied for domestic use. Their wastewater is treated, then moves to the drinking water network. And if there is such a situation in Turkey, you can study. Any question? So you see that so far I suggested some topics interesting to me that you can find suitable published papers and then talk in the class. Actually, for both seawater and reclaimed water, in some conventional sources. Conventional sources are groundwater and surface water, and non-conventional ones are the combination of seawater, reclaimed water, and also some new generations of the water resources like rainwater harvesting. Yeah, this is rainwater harvesting is also one type of non-conventional sources that this rainwater harvesting is received high attention in Turkey recently, and I will talk about it more in the next slide. Let's follow the lecture. Particular focus is placed on reusing wastewater in agriculture, improving water efficiency in the agricultural sector, drainage water use and saline water use in agriculture, rainwater harvesting, and small-scale desalination projects, seawater or brackish water. In a country where agriculture accounts for more than 73% of the country's water use, significant efforts should be made to improve the efficiency, as the potential for water conservation is far greater in agricultural than in other water using sector. Reduce conveyance losses and improved irrigation efficiency, for example, can result in water saving in irrigation sector. You know what the lecture says? The lecture says in Turkey, we know that 74% of water is used for irrigation. And unfortunately, the most part of this water we lose the most of this part. All of those water does not move directly to use in the irrigation, and about 50% or 60% of this water that we use for irrigation, we lose it without achieving our goal. Therefore, serious attention is needed to be manage the water that is used for agriculture. And two common ways is use of sprinklers and drip irrigation systems. In drip irrigation, you see here, in drip irrigation, water loss is minimal and range from 5 to 20%. In order to reduce water loss in agriculture and to be used in sector where there is water stress in saving water, it is necessary to spread, sprinkle, and dripple sprinklers and drip irrigation system. Okay. And finally, talking about rainwater harvesting in Turkey as a non-conventional water. What is the rainwater harvesting? Actually, the system of rainwater harvesting works similar to system of water collection in a catchment. You see, in a natural catchment, we have precipitation, and the river network collects precipitation after infiltration process. The runoff moves to the outlet. And in the outlet, for example, here we make a reservoir or dam to store the excess runoff to use when we need. The similar concept is used here. Instead of one catchment, we have our home, yes? And therefore, how the amount of water that falls as a rain on the roof can be collected and stored in a tank. And then this water can be used for some goals. For example, for garden watering, or for cleaning of the yards, for, I don't know, washing the cars in case that we have some filters here. And actually, yes, I don't have details of design, but we can design this tank with some filters here, that this water comes before going to the tank. It can be filtered, therefore quantity of the water in the tank can be controlled. Then it can be used for different reasons. As you know, since 2021, Turkey government made a rule to construct these systems when they built new buildings. Let's see its definition. In other areas, a rain water collection system is now required for buildings constructed on parcels larger than 2,000 square meters. If any parcel is higher than 2,000 square meter, at least rainwater harvesting system should be designed. Details was provided by Ministry of Environment and Urbanization, amendment of the planned area zoning regulation, which was published in 2021, and here I share that rule with you. As you see here, if a parcel is higher than 2,000, rainwater harvesting system should be constructed and used. Okay, that's all for today's lecture. If there is any question, please go ahead. Any question?
Thanks, sir.
No question.
No,
Thank
Professor.
you.
Thank you, sir.
Okay.